maximum distance that a meter base can be away from a residential panel is 100 feet. This limitation is in place for several reasons, primarily related to voltage drop, safety, and the practicality of electrical installations. Voltage drop refers to the decrease in voltage that occurs along a conductor as electricity flows through it. The longer the conductor, the greater the voltage drop. Excessive voltage drop can cause appliances and equipment to operate inefficiently or even malfunction. For example, if a refrigerator receives significantly less than its rated voltage, its motor may overheat and fail prematurely. Similarly, lighting can dim noticeably, and sensitive electronic devices may not function correctly. To mitigate voltage drop, electrical codes, such as the National Electrical Code, often specify maximum allowable distances for conductors based on their size and the amount of current they carry. The 100-foot limitation for the distance between a meter base and a residential panel is intended to help ensure the voltage drop remains within acceptable levels. This distance is generally considered a reasonable compromise between flexibility in locating the meter base and maintaining adequate voltage at the panel. In situations where the distance between the meter base and the panel exceeds 100 feet, several measures can be taken to address potential voltage drop issues. Firstly, larger conductors can be used. Increasing the size of the conductors reduces their resistance, thereby minimizing voltage drop. The specific size of the conductors required will depend on the amount of current being carried and the distance involved. Electrical engineers and qualified electricians can perform calculations to determine the appropriate conductor size. Secondly, voltage drop can be calculated to ensure it is within acceptable limits. The National Electrical Code typically recommends a maximum voltage drop of 3% for branch circuits and 5% for feeders. If the calculated voltage drop exceeds these limits, adjustments must be made, such as using larger conductors or reducing the distance between the meter base and the panel. Thirdly, the location of the electrical panel relative to the meter base should be carefully considered during the design phase of a building. Ideally, the panel should be located as close as possible to the meter base to minimize the distance between them. In some cases, it may be necessary to relocate the panel or the meter base to comply with the 100-foot limitation. Another important consideration is the type of wiring used between the meter base and the panel. Underground wiring is generally preferred, as it is less susceptible to damage from weather and other external factors. However, underground wiring can be more expensive to install than overhead wiring. The choice between underground and overhead wiring will depend on factors such as cost, site conditions, and local regulations. The meter base is the point where the utility company connects its electrical service to the building. It typically contains the electric meter, which measures the amount of electricity consumed by the building. The meter base is usually located on the exterior of the building, where it is easily accessible to utility company personnel. The electrical panel, also known as the breaker box or load center, is the main distribution point for electricity within the building. It contains circuit breakers or fuses that protect individual circuits from overloads and short circuits. The electrical panel is typically located inside the building in a readily accessible location such as a basement, garage, or utility room. The connection between the meter base and the electrical panel is typically made with a set of conductors known as service entrance conductors. These conductors are sized according to the electrical load of the building and must be installed in accordance with the electrical codes. The National Electrical Code provides detailed requirements for the installation of service entrance conductors, including their size, type, and protection. When installing electrical wiring, it is essential to follow all applicable electrical codes and regulations. These codes are designed to ensure the safety of people and property and to prevent electrical hazards such as fires and electric shocks. It is also important to use qualified electricians who are familiar with local codes and regulations. A qualified electrician will be able to properly size conductors, install electrical equipment, and ensure that all wiring is done safely and correctly. The 100-foot limitation for the distance between a meter base and a residential panel is just one of many electrical codes that are in place to protect people and property. By following these codes and using qualified electricians, homeowners can ensure that their electrical systems are safe and reliable. The electrical system in a home is a complex network of wires, circuits, and devices. It is important to understand the basic principles of electricity and how the electrical system works to ensure that it is used safely and efficiently. Electricity is the flow of electric charge through a conductor. The amount of electric charge is measured in coulombs, and the rate of flow of electric charge is measured in amperes, often called amps. Voltage is the electrical potential difference between 2 points in a circuit. It is the force that drives the flow of electric charge. Voltage is measured in volts. Resistance is the opposition to the flow of electric charge. It is measured in ohms. Ohm's law states that the voltage across a conductor is equal to the current flowing through the conductor multiplied by the resistance of the conductor. This law can be expressed as volts equals amps times ohms. Power is the rate at which electrical energy is transferred. It is measured in watts. Power can be calculated by multiplying the voltage by the current. This can be expressed as watts equals volts times amps. Electrical circuits are classified as either series circuits or parallel circuits. In a series circuit, the components are connected in a single path, so the current is the same through all of the components. In a parallel circuit, the components are connected in multiple paths, so the voltage is the same across all of the components. Circuit breakers and fuses are safety devices that protect electrical circuits from overloads and short circuits. An overload occurs when the current in a circuit exceeds the rated capacity of the circuit. A short circuit occurs when there is a low resistance path between 2 points in a circuit, causing a large amount of current to flow. When an overload or short circuit occurs, the circuit breaker or fuse will trip or blow, interrupting the flow of current and preventing damage to the electrical system. Grounding is an important safety measure that helps to prevent electric shock. Grounding provides a low resistance path for current to flow back to the source in the event of a fault. This helps to trip the circuit breaker or fuse, interrupting the flow of current and preventing electric shock. Electrical safety is essential to prevent electrical hazards such as fires and electric shocks. Always follow electrical safety precautions when working with electricity. Firstly, turn off the power to the circuit before working on it. Secondly, use insulated tools. Thirdly, never work on electrical equipment when you are wet. Fourthly, inspect electrical cords and plugs regularly for damage. Fifthly, do not overload electrical circuits. Sixthly, use ground fault circuit interrupters, often known as GFCIs, in wet locations such as bathrooms and kitchens. Seventhly, call a qualified electrician for any electrical repairs or installations that you are not comfortable doing yourself. Electrical codes and regulations are in place to ensure the safety of people and property. Always follow these codes and regulations when installing or repairing electrical wiring. The National Electrical Code is a widely adopted standard for electrical installations in the United States. It provides detailed requirements for the installation of electrical wiring, equipment, and systems. The National Electrical Code is updated every 3 years to reflect changes in technology and best practices. State and local jurisdictions may also have their own electrical codes and regulations. It is important to be familiar with the applicable codes and regulations in your area. The electrical system is the heart of a home. By understanding the basics of electricity, following electrical safety precautions, and complying with the electrical codes and regulations, you can ensure that your electrical system is safe, reliable, and efficient.